Hello friends, let us try to obtain a block diagram for the system which we have considered in the previous example. For easy understanding, I have reproduced the differential equation of the system along with the state equations. If you remember, we have defined the first state variable x1 as the output itself, that is x1 equal to y, and we were able to write the second state variable x2 as the derivative of the first state variable. Hence we obtained equation 3, and the third state variable x3 is the derivative of the second state variable. Hence we got equation 4. Correspondingly, we got another equation x3 dot as equal to the linear combination of x1, x2, x3 and u, such that x3 dot equal to minus 6x1 minus 11x2 minus 6x3 minus u. This was dealt in my previous lecture. So now what we try to do is we will try to obtain the block diagram for these equations. So the block diagram has to satisfy these equations, or in other words, we need to synthesize a diagram which will substantiate these equations. Alright, let us begin with the input variable u. Put a summer. Let us try to take x3 dot as the output of this, wherein you may require inputs here. We may require another input. We may require another input. We may require all these things. So x3 dot, we may require the summation of all these signals. x3 dot should be 6 times x1 minus 11 times x2 minus 6 times x3 minus u. So we'll try to pass this, we'll try to get these signals. Try to see as we go about. x3 dot, we will pass through an integrator, and what we get here is x3. x3 dot, when integrated, you will get x3. And from equation 4, this x3 is equal to x2 dot. Now we will pass this x2 dot through another integrator. What you get out of it is x2. And from equation 3, x2 is equal to x1 dot. We'll pass it through another integrator. So what do we get out of it? Is x1. x1 dot, when integrated, you will get x1. Now we will try to get these signals from these outputs. So minus 6 x3, I have x3 here. I'll try to take a point of this particular location, pass it through a block having minus 6, take it here. So x3 when multiplied with minus 6x3 is coming, that is getting added here. And here I am getting x2, I'll take off a signal from x2, then try to minus 11, and I'll get that x1, this is minus 6 x1. Now x1 equal to 1. This completes the block diagram of the given problem. If you see here, so x1 equal to y is this equation, x1 equal to y, and here x2 equal to x1 dot, equation 3. At this location x3 signal is x2 dot, this equation. Now x3 dot is equal to, sorry, I'll take, I've done, we might as well take this as minus 1, then I'll have minus 1. So u minus u, and the signal is minus u, and here you are getting minus 6x3, minus 11x2, minus 6x1. They're all getting added up. You are getting x3 dot. When integrated, you will get x3 equal to x2 dot. Integrated, you will get x2 which is equal to x1 dot. Another integration will give you x1, that's equal to 1. This is the block diagram of the given system. Few interesting facts can be observed here. The system matrix for this problem, as we have seen earlier, is equal to 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6. From the equations 2, 3, 4, the 3, 4, 5, we can write the system matrix A as equal to 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6. So if you look at these equations, you can write the matrix A. Say when we model a linear control system using phase variable method, given the differential equation, we can write the system matrix A by inspection. The system matrix A is written as first row being 0, 1, 0. The second row has got 0, 0, 1. And the third row, if you see, is the negative of the coefficients taken in the reverse order. Thus, minus 6 corresponds to the negative of this y. Minus 11 is the negative of the coefficient of y dot. Minus 6 is the negative of the coefficient of y double dot. And this particular form of system matrix is called Bush form, or also called companion form. It has to be remembered that in this form, the first element of system matrix is always a 0, and it has got 1 as a second element, and the remaining elements are 0. And correspondingly, the elements would go on in the various rows, and the last row of the system matrix consists of the negative of the coefficients of the output and their derivatives taken in reverse order. Okay? Thank you.